Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. How are y'all doing? Now today, as promised, I'm going to have a look at this video, the Lunar Eclipse from the Flat Earth Institute of Science. And this was featured on Globebusters recently. Now I put this up and I encourage my viewers to go have a look at it and see if they had any problems with it. And now I'm going to go ahead and review it and tell you what I found on it. You can compare that to what you noticed and see whether or not maybe you picked up something that I didn't. So let's cue up the music and get going. Now, as you're very well aware, we are very familiar with the orbit of the moon around the Earth and the orbit of the Earth around the sun. We understand both solar and lunar eclipses very well and can predict them down to the second, literally hundreds of years in the future. However, the Flat Earth Institute of Science thinks that that's all wrong, and he has an alternative explanation for the lunar eclipse. Now, all good science starts off with what is initially considered a crazy idea. Albert Einstein, for example, with special relativity. This was a completely new way of approaching the universe, and it flew in the face of convention at the time. So I would never berate somebody for coming up with an alternative explanation for what we currently feel we understand. However, in order for that alternative explanation to work, you have to be able to not only predict everything our current model predicts, you have to do it better and predict things that our model struggles with. So let's go see whether or not he meets his burden of proof here.
Many globe earthers love to point at lunar eclipses and act as if they were solid proof that the Earth is a globe. The problem is, they don't prove it's a globe. Let me show you. Here I have a ball, and I'm going to cast the shadow of this ball onto another ball. All right? Look carefully at the shape of that shadow. Now here's the shadow of a ball being cast onto a plate. And please take notice of how the shadow is different here. Here's the shadow on a ball. Shadow on the plate. Now here is a picture of a lunar eclipse. I don't know about you, but I think this presents a problem for the globe Earth model.
Now this is a very interesting observation that he's made, but did he make the observation correctly? Now let's look at a couple of things here real quick. Let me pop out of here and I want to point out a few things on the screen. Now, right here, we have his experiment with this basketball. Now you see the round basketball, you see a little bit of the shadow here, indicating that the light is coming in from this general direction. Then you have this flat, or apparently flat, shadow across the surface of the basketball. And then I want to draw your attention to the step of the round shadow in the background to the edge of the basketball, and then it comes down, straight across, and then it gets to the other side of the basketball, it comes up and goes back to a round shadow. Now the one thing that I noticed in this right off the bat was the fact that the shadow is curved on the background, but straight on the spherical basketball. All right, so let's look at his next example. Now I honestly don't know if he's suggesting that the moon is flat, in which case he should research the flat moon. But you clearly see a curved shadow, both in the background, on the plate, and in the background again. Now the interesting thing is right up here in the center, and that is the shadow on the moon. It's clearly curved. Now on first blush, it would appear as though he is suggesting that the moon is a disc-shaped rather than a spherical object. And as absurd as that is, we can certainly consider it. However, did he take his observation correctly? What is our point of view when we look at the moon during a lunar eclipse? Our point of view is from Earth, the surface of the Earth, not from any other point in space, above the Earth, below the Earth, to the left or the right of the Earth in the orbit, from the Earth itself. Does that perspective make any difference? Well, let's go ahead and have a look. Now, one other problem that I noticed and I want to address before we go on to my actual experiment is the size of the Earth's shadow. The Earth's shadow is approximately 2.6 times the diameter of the moon. That is conservatively 7 or 8 times the diameter of the moon. So by starting off with a massive shadow like that, you're already flattening the curvature of the shadow on the surface of the moon. And that's because the shadow is so much larger than the moon, it's already starting off as a flattened curve. So let's go up to my experimental setup. All right, so what I did to start off with was I got something to use as the moon, and it was this ball right here. Now, I put it on a soup can, and I put it right up against a cardboard box, and some distance away I put a light source and shone it on there and measured the shadow of the moon, and it was 5¼ inches. So what I did was I went out and I took a second sphere, approximately the same size, and I set that up on a soup can, and I created a shadow using the same light source. So here you see the measurement of the shadow of my moon analog right next to the box, and it's about 5¼ inches. And here you see the more reasonably proportioned shadow of the Earth. Now, obviously, this is not truly to scale, because if this was the moon, the Earth would have to be probably 16 meters away in order to actually have the correct size, and it would be about 1/2 meter in diameter. The sun would be 5 kilometers behind me and 30 meters in diameter. I obviously couldn't do that in my living room using a smaller sphere to cast the shadow and a much closer light source. But I got the shadow sizes about right. So let's see what happens when I vary where the camera is located. Now, just to give you an idea of the setup, I have my camera directly above the flashlight, looking right down the flashlight. So I'm very close to the source of light. But as you can see, the blue there is the curve of the near sphere, that Earth sphere that I was using. I'm still well above it. But what I want to draw your attention to is right here. You notice that this is not only a curved line, but there's that little step right there and a little step right there. That's because I'm above the surface of the Earth. That step would not be there if I was down on the surface of the Earth. Let's see what happens when I move the camera away from the optical axis here. I'm going to move it up. Now I want to call your attention to two things here. First of all, let's go back right there. Look how flat that is. Look how flat this appears. Note the step for both the shadows and the fact that the shadows themselves are curved. But on the surface of the sphere, when we're well above the axis that we would be viewing the eclipse at, we can make that appear to be flat. But what happens when we come back down? Now it's curved again. Even though we're still not perfect, you see there's a little step there and it's a little worse up here. But even that's curved up top. So the idea that the shadow across the surface of a spherical moon would be flat is due to the fact that we're not looking at that shadow from Earth. Now, I don't think that he was deliberately attempting to falsify this, such as Mitchell and Rob Skiba did. I think he just didn't think it through very well. You have to be aware of your point of view or your frame of reference. And then you have to try and reproduce that frame of reference when you conduct your experiment. So to do this correctly, he should have looked at this from the standpoint of the Earth itself, and then looked out at what kind of shadow was cast on the moon from the Earth. As you can see, it's curved. So let's move on to his next claim.
But I don't think it's the shadow of the Earth being cast on the moon here. I think something else is going on. The shadow of the Earth is not the only thing that could cause the moon to turn dark. What if this has to do with some kind of a filter that comes between the Earth and the moon? A little while back, I had the opportunity to interview Cami Nodell, and she taught me some really fascinating facts about the atmosphere that I was totally unaware of before. She taught me about how the atmosphere acts as a filter and polarizes the light that passes through it.
Things that people don't understand about that happen in reality, things that we should be looking at. The atmosphere polarizes any electric field, polarizes light. Any light that's polarized is directionalized, polarized filters crossing, have different effects.
And you know how I'm always on the hunt for common ground. Here I found some common ground with Colorado State University, wherein they acknowledge the fact that the light from the sun gets polarized as it passes through the atmosphere. And they further claim that bees actually depend on this polarization for navigation. That is pretty wild and mind-blowing if you ask me.
Now, I found this claim rather fascinating because I really wasn't aware of how sunlight was polarized in the atmosphere. I do know that glare from the ground polarizes light, and that's why Polaroid sunglasses work. Now, the reason that you do have polarization of the sunlight has to do with the position of the sun. If you were to draw a line from the celestial position of the sun across your field of view, light 90 degrees to that angle would be about 70% polarized, and that is due to the Rayleigh scattering of light by the molecules in the atmosphere, the same reason that the sky is blue. So basically, a bee's eyes, for example, can pick up this polarization and get a direction to the sun simply by looking at a patch in the sky. All right, that's a cool thing to know when you're trying to figure out your way back to the hive from that cool flower you just found. But the bottom line is it has absolutely nothing to do with the magnetic field around the Earth, but it occurs every single day. We do not have a lunar eclipse every day. We don't have a lunar eclipse every month. There are very specific conditions that have to occur in order for a lunar eclipse to occur, and specifically, the Earth has to pass between the moon and the sun. Simply claiming that this is polarization of the atmosphere makes no sense whatsoever. Probably the major reason that this is a completely untenable hypothesis is the vast majority of solar eclipses do not occur when the sun is visible in the sky. And you have to have the sun visible in the sky to have polarized sunlight visible. So, quite frankly, it's dismissed. However, his next point sort of addresses this. So let's go on and have a listen to that.
One very important vocabulary word that everyone interested in lunar eclipses should learn is the word selenelian. This is kind of an essential term for flat earthers to know. A selenelian is a lunar eclipse that takes place while the sun is visible. And this particular multiple exposure image was featured in the NBC News back in 2014. Though if you want to look up that particular lunar eclipse, the photo was actually taken in December of 2011. Anyway, according to the description here, this photo shows the setting moon just as the sun was about to rise. So the moon is going down in the west, and the sun is coming up behind the observer in the east. And please notice how the moon is being lit up from the bottom up. Now let's try and visualize how the mechanics of this would work in Dr. Thaler's globe Earth model. If we were to put the eclipsing moon in here, where should we put it? Should we put it here? That doesn't seem right. The moon here is setting and should be moving into the shadow, in which case the light here appears to be on the wrong side. How about somewhere down here in the bottom half of the shadow? That looks a little better. The number one explanation I have heard globe earthers provide when trying to explain selenilians is that refraction is causing both the sun and the moon to be visible. That is some pretty extreme refraction if you ask me. High above the mountains even. And look, that moon is not showing any signs of distortion. I'm glad that we can agree that refraction is possible so high up in the air without any signs of distortion. That is some pretty significant common ground right there.
Okay, this is probably my favorite part of this entire video, the selenilian eclipse. Now, notice a couple of things that he has problems with. First of all, why is the moon lit from the bottom side of it, as he puts it, rather than the top? Second of all, why is there absolutely no distortion in this, even though there's supposed refraction going on? I mean, the moon doesn't change at all. Or does it? Let's have a look at a couple of things. First of all, this is a setting moon. We're looking west. Here the moon is high in the sky. What's the sky like during that moon? That's nighttime. The sun is just starting to come up. It starts off at night and it works its way down towards dawn. That is a given from his explanation. So not only did he confirm it, so here's the original NBC News article from this selenilian eclipse. What's the big thing they're talking about here? They're talking about how abnormal this is because you are getting the sun and the moon in the sky at the same time. And in very select locations in the western part of the United States, where the lunar eclipse was still ongoing as the sun was coming up, you could experience this selenilian eclipse. And they talk about it right in here. And there's the image that he was using. Now, the next thing that I really want to talk about is his claim that there's absolutely no distortion of this image. So let's go ahead and have a quick look at it. So here's our image. First of all, what time of the day is this particular image taken in this series? This is taken at night. The moon is high in the sky and it's dark out. However, as the day goes on and we get closer and closer to sunrise, which would have the moon down here, look at the color of the moon. Do you notice how that becomes pinkish red? It's definitely changing. Now, the other thing that you'll run into as well is as the moon gets closer to the horizon, you're going to get increased refraction and the moon will start to loom. What part will loom the most? The lowest part, which is the bottom of this crescent. So if you look at the image of the moon high in the sky, notice the curvature of the bottom of the moon. Now, even though this is a little bit more of a sliver of the moon, you should be able to fit this into this curvature. But notice how it's flattened here at the bottom. That is the looming seen in the lowest limb of the moon. So this entire thing is being pushed up in the middle here. Not only is it getting this red tinge from the scattering of light as it goes through the atmosphere, which is not present when the moon is higher in the sky, but when it's right down at the horizon, you've got a lot more atmosphere to go through. As a result, you get more light absorption, and the moon has this blood color to it. And the crescent itself is flattened because of the looming. So his idea that there's no change or no evidence of refraction in this picture is debunked. Let's go on to why is the shadow on the upper part of the moon? Well, let's go ahead and have a look at that lunar eclipse. So here's the actual write-up of the lunar eclipse from December of 2011. Now, one thing that's very important to notice is right here behind my head. Here is the path of the moon going through the shadow of the Earth. The gray here is the shadow of the Earth. The path of the moon you can see right here. the shadow will be on the northern aspect of the moon. Now here you see the entire sequence of the lunar eclipse. Here's your full moon, because all lunar eclipses only occur during very specific full moons. You see the shadow coming in from below. It obliterates the moon here. And then the sunlight begins to come in from above on the opposite side. You see it's coming in from about the 11 o'clock position here, and it's coming in from about the 2 o'clock or the 1 o'clock position here. Why is this shadow on the bottom of the moon here, but on the top of the moon in the images that we saw in the video? Because this sequence was taken from Australia in the southern hemisphere, and everything on the moon is reversed because the Earth, of course, is a sphere. So if we're seeing the light coming in at the top aspect of the moon in the southern hemisphere, the light will be in the bottom aspect of the moon in the northern hemisphere, exactly as we see it. I think the Flat Earth Institute of Science is suffering from a northern hemisphere bias. They seem to look at everything from the point of view of the northern hemisphere without considering the fact that sometimes the moon kind of favors the southern hemisphere, as it did here. So there we have it. The globe is not being debunked. It's just another example of sloppy science on the part of the flat earthers. Now, we've gone over how to manipulate the shadow on the surface of the moon. We've gone over polarization of the atmosphere. We'll see why that doesn't affect the moon as he claims it does, because if his claim was true that it caused eclipses, it would also interfere with other phases of the moon present around sundown and sunup. So, for example, we would have a crescent moon cut in half top to bottom because of polarization. That simply does not occur, and his proposal is literally nonsense and can be dismissed. Finally, we looked at the Selenelian eclipse, saw how it occurred. We looked for and found actual evidence that refraction was playing a role in the Selenelian eclipse. So, this is Bob the Science Guy signing out from Northern Michigan. Thank you again for joining me. I want to thank my Patreon's members and subscribers to this channel. Without you, I couldn't get all the cool stuff that I try and bring to the channel. So keep up the good works, keep those super chats coming, and consider becoming a member of the channel. Until next time, take care, my friends.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.